Welcome everyone. So in this series of videos, I will be solving some KTU previous year problems. So this problem is from MOS Civil Engineering S3 exam. This was asked in 2017 December for 10 marks. Okay, this particular problem is from module 5. In module 5, this is from the column part of the module 5. So the question is, find the buckling load given by Rankine's formula for a tabular strut hinged at both ends, 6 meter long, having outer diameter 15 centimeter and thickness 2 centimeter. Given that modulus of Young's modulus is 2 into 10 to the power 5 MPa, maximum compressive strength is 567 Newton per mm square, sigma C. Rankine's constant A is 1 upon 1600. Find the length of the column. For what length of the column does the Euler formula ceases to apply? Okay, so this is a direct question with formula based question. Remember that in the column portion you have to remember two formulas. One is the Rankine's formula, second is the Euler formula. Okay, there is also a small formula which is for short columns. When we do problem related to that, we will solve that. Right. So the question what they're given is there is a column. There is one column. The length of the column is given as 6 meter. 6 meter, and it is hinged at both ends. So this is a hinge. So make sure that you draw the diagram. This is hinged. Okay. And it is a tabular column, meaning the cross section we have an outer diameter and inner diameter. 15 centimeter is the outer diameter. That means outer diameter capital D, which will call as capital D, is 150 mm. Okay, and the inner thickness is 2 centimeters. So this is 20 mm here, thickness 20 mm thickness here. So that means the inner diameter will be 150 minus 20 minus 20. So 150 minus 40, that is 110 mm. Okay. Then what is given? Then E is given. Other data given is E is given. Young's modulus 2 into 10 to the power 5 MPa. Always remember 1 MPa equal to 1 Newton per mm square. Okay. Now sigma C is given. So that is maximum compressive strength of the material. It is 567 MPa. Okay, then Rankine's constant is given, that is 1 upon 1600. Yes, so that is given. Now, any column problem, first, the moment you get the length of the column and boundary condition, you have to find the effective length. So, effective length of the column LE, which is nothing but for hinge boundary condition, effective length is same as length. That is same as 6000 mm. So 6 meter, that is 6000 mm. So when the conditions both end are hinge and hinge, then the effective length is 6000. If both ends are fixed, the effective length will be half of this. Okay, so it depends upon the end conditions or boundary conditions. Is very, very important. This is what is known as boundary condition, end conditions. So when it is hinged and hinged, the total length, original length, we have to consider as the effective length. Now they are asking us to find the maximum load based on Rankine's formula. So Rankine's formula, you should remember the Rankine's formula. It is given by sigma C into area of column divided by 1 plus Rankine's constant into LE upon K the whole square. Okay, so remember in this K is what is known as radius of gyration. So it is nothing but radius of gyration, the minimum value, least value. Okay. So if it is a rectangle cross section, we can get 2 radius of gyration, but for a circular or hollow circular cross section, we will have only 1 radius of gyration for the formula for the cross section. Now, this is a geometric property. How do you find the radius of gyration? Now let's see what all formulas values we know. We know sigma C is given to us. Area we can calculate. Effective length we know. We have to calculate K. A is given to us. We have to calculate K and we have to calculate A. So let's do that. So there is another way of writing this formula. So that is also something. Okay, we will find each value, substitute, and then solve it. Okay, that will be easier for us. So let's say, what is the area? Area of the column is nothing but pi by 4 into 150 square minus 110 square. So what is this value? We will just find out the value quickly. So this is pi by 4 times 150 square minus 110 square. So this gives us 2600 pi, or 8168 mm square. Okay. Now K, how do you find K? To find the K, you know that we have to find I, because we will use I equal to moment of inertia is equal to AK square. Okay. So this is how you find K. The moment of inertia is equal to AK square. Area is cross section, radius of gyration I. Now moment of inertia of this hollow circular section we have to find. So this will solve. We know the formula for hollow circular section. The moment of inertia is pi by 64 times capital D to the power 4 minus small d to the power 4. Okay, so this is nothing but pi by 64 times capital D to the power 4 is 150 raised to the power 4 minus small d raised to the power 4, 110 raised to the power 4. So this gives the value as, so we'll just calculate that very fast. So we have pi by 64. It's a very big value that we are going to get. 150 to the power 4 minus 110 to the power 4. Okay, so this is 17663604. So 17663604. mm to the power 4. Right. So this is the value of I. Now we can find the value of K here. So just make some space here so that everything can be visible on the screen. So K equal to under root I by A. So this is nothing but under root of 17663604 divided by 8168 to the power 1 by 2. So let's do this. Now this is there. What we have to find is under root of answer divided by 8168. Okay, so this answer is nothing but the value of I. It is 46.5 mm is the, so unit of K will be mm. So 46.5 mm is the radius of gyration. So we have got the value. Now we have found every value. We just have to substitute. Let's find LE by K whole square. What is LE by K? LE by K is nothing but effective length is 6000. 6000 by 46.5. Okay. So this comes out to be 6000 divided by, answer will give me 129.023. So equal to 129.023. Okay, this is LE by K. So LE by K will be unitless constant. Now let's substitute these things in the equation and find the value of P. So P equal to sigma C is known to us. What is the value of sigma C? 567. Area of cross section is known to us. What is area of cross section? 8168 divided by 1 plus value of A is given 1 upon 1600. LE by K is 129.02 square. Okay, so we'll just solve this. So first I will find the square of this will give me LE by K square This is LE by K square. So divided by 1600. Give me 10.4 plus 1 will give me the denominator. So 11.4 is the denominator. So we know that it is 567 times 8168 divided by the answer will give me 406092 Newton. Okay, or nothing but 406 kilonewton. 406092. 406092 Newton. Or we can say 406.1 kilonewton. So this is the load as per Rankine's formula. Now there is second part to the problem. The second part is they're asking for what length of the column does the Euler formula ceases to apply. Okay. Now there is no factor of safety or something given in this formula. So this is the answer, final answer for the load. If factor of safety is given, then you have to divide by factor of safety to get the safe load. Okay. So some questions it will be given, but in this question it is not given. Now, what is the length of the column does the Euler formula ceases to apply? So I'll just explain what is the meaning of this problem, this part of the question. Okay, I'll write it here. So let's say. So this column, we know that the column can be short column, it can be long column. Okay, the short column we use the short column equation to find the strength, that is sigma c into area will give me the strength of the column. For long column we will use Euler's formula. Okay, so we know that for short columns, if you use the Euler formula, whatever value of axial load capacity that you get, it will come out to be more than this value. Okay, more than sigma c into a, which is practically, it doesn't make sense. Okay, so there is some length of column beyond which we can use Euler's formula. Less than that length, if you start using Euler's formula, what happens is the value of Euler's formula will come out to be more than the value based on the strength, compressive strength. Okay, so which doesn't make any sense. So this is the critical length. So after this length, we can start applying the Euler's formula. After this length, the value from Euler's formula will be always less than this value from the compressive strength. Okay, so this is the length that they are trying to ask. So basically, this is the length in which the Euler's formula and the normal column strength using compressive strength both will give the same value. So we can say that the critical length is that length in which both Euler's formula and the short column formula both will give the same value. So that means sigma c into A will give me the strength due to Euler's formula. So Euler's formula is pi square E I upon LD square. So this formula you are expected to remember, sigma square into A. So this is nothing but sigma c into A equal to pi square E into A is nothing but AK square upon LE square. Okay, so this area we can cancel out here, area we can cut out. We can find the value of LE square equal to pi square E into K square upon sigma c, and LE equal to under root of pi square E K square upon sigma c. This comes out to be, we will substitute the values, pi square into, what is the value of E? The value of E is 2 into 10 to the power 5. 2 into 10 to the power 5. Okay, into K. Value of K is nothing but 129.02. 129.02 square divided by sigma c. The value of sigma c is 567. If I remember correctly, it is 567. Yes, it's 567. 567. Now what is this? Let's calculate this quickly. So this is pi square times 2 times 2, 3, 4, 5 times 29.02 square divided by 567. So it is 7612 mm. 7612 mm. So this is the effective length. So above this length, we can safely use Euler's formula because that will give lesser value. Lesser than this length, so my original length also will be, since it is simply supported, it is same as effective length. So 7612 mm. Okay. So less than this length, Euler's formula will tends to give more value than the short Coulomb formula. Okay. So I hope this is clear, and this is direct formula based answer. So these two part you have to solve. Once you solve this, you can easily get the answer. Okay, so this is this problem. We will again solve another problem in the next video.